Everyone, in today's video we will have an example on solving discussing about the similar solids. So we have here two similar solids or pyramid, but they are not in the same size. So our problem now is to find the volume of the larger pyramid, given that the surface area of the smaller pyramid is 16 centimeters squared, and then our volume is 20 centimeter cube, and the surface area of the larger pyramid is 20 centimeter squared. So we will find the volume of the larger pyramid. So the ratio of the surface area of two similar solids is equal to the square of the ratio of the corresponding linear dimensions. So the ratio of the volume of two similar solids is equal to the cube of the ratio of their corresponding linear dimensions. So let S1 our surface area for the smaller one, and for V1, which is our S1 is 16 centimeter squared, our V1 is 20 centimeter cube, and for our S2 we have 25 centimeter squared, and for our V2 or volume 2 is still unknown, so we will find that one. Now the ratio of the surface area a while ago is equal to the square of the ratio, so we have here S surface area 2 over surface area 1 is equal to 25 over 16. Since the ratio of the surface area is square to the ratio of the linear dimension, then we will let k be the ratio of the linear dimension. So k squared is equal to our linear here 25 over 16. So for us to eliminate the square, we will square both sides. So 20, this one is cancelled, so k, the square root of 25 is 5, and the square root of 16 is 4. So this one is our k, or the linear dimension. So for us to get the ratio of the volume of the cube, ratio of the volume is the cube of the ratio of our linear dimension. So for this one, well, volume 2 over volume 1 is equal to k cube, right? Because cube, volume is cube of the ratio of the linear dimension, which is our linear dimension is 5 over 4. So our k is 5 over 4, then raised to the power of 3, which is 5 times 5 is 125. 125 over 4 to the power of 3 is 64. Now we can solve for our V2 or volume 2. So for the volume 2, our formula is V squared. V2 is equal to V1 times our linear dimension, which is 125 over 64. So we will substitute this one. It becomes, what is the V1 or volume 1 is 20 centimeter cube times 125 over 64. So we will just multiply this one. This has the invisible one. So 125, it becomes 2,500 over 64. To make this one, to simplify this one, we will divide this one by 4. So 2,500 divided 4 is equal to 625 over 16, which is 64 divided 4 is 16, or it is approximately 39.06 centimeter cube. So the volume of the larger pyramid is approximately 39.6 centimeter cube. So that is 39.6 centimeter cube. So that is our volume 2. Now let's proceed to another example. Example for scale factor in finding the length, area, volume in a similar figure. So we have here, we're looking for the surface area of the cones, and the only thing we have is to go on here is the radius. Now they tell us the problem, which is the problem that the two cones are similar. So all we have to do is to look like the scale factor is to look for the scale factor, and it is more likely 1/2, because this is the new one and this is the old one. Now we divide by the new one, divide by the old one. Now we will take the scale factor and square it, because we're comparing the areas of the two dimensions. So 1/2, right? 1/2 squared. So that means that the ratio area is 1/4, right? 1/4. Now when comparing, it is easy to see which is the smaller and the larger, right? We can see that one. So now 1/2 squared is equal to 1/4, and for our larger, yes, surface area is 20, and we will find the x. So we'll just cross multiply it. So we have, so by cross multiplying it, we get 4x is equal to 20, and we divide both sides by 4, so we came up with x is equal to 5 unit squared. So that is our surface area for the smaller one. So that's it for this video. Hope that you have learned something.